Here we go. This is AP lesson 1.1. Very short lesson. You can probably read through this on your own, but the goal of statistics is to make decisions based on data. And there's a lot that goes into that. There's good data, there's bad data. How do you get good data? How do you get data that doesn't have a bias? And so we're going to talk through all of these things. Chapter 1 is kind of about how do you set up a good study. How do you get data? What are the types of biases that we can encounter? We typically make decisions about a population by considering a random sample of the population. Lots of times you can't get data from an entire population, like what's the average height of every person in the world. But what we can do is we can take a sample of the population, and you got to be careful on how you take a sample, because we want, I'll get into that. The population is the entire collection of individuals. A census, which we're in the midst of, is an ideal but often not attainable study that collects from every individual. So we have data on every individual that we're interested in, whereas a sample is a subset of individuals in the population for the study. It is important that the sample be both random and representative of the population. These are going to be two big driving factors in a lot of our questions. Before you can do any type of statistics, you have to verify that your sample is random and it's representative of the population. So for example, if we asked what is the average SAT for students at Chesterton High School, so we're going to gather data and we're going to find the average. Easy enough. However, before we do that, is the sample that we are taking random? Because I'm assuming that you don't have data on everybody's SAT score. And is it representative of the population? So if we just took our class, we're like, you know what? Let's find the average SAT score for Chesterton, and we'll use our class as the sample. So we'll just look at our averages. Do you think that would be a good sample to use? Probably not. And then, because probably our SAT scores, we're a higher level math class, we're going to be a little bit above average. Okay? So would our class be a good sample of the population? No. It doesn't. Our class does not represent the entire student body, and our class wasn't really random. So we're going to go through some methods about how you can be random and how you can represent the population, and that's as we get into chapter 1. So the big takeaways is a real quick lesson. There are two types of statistical studies to get data to compare groups. The first one is called an observational study. The second one is called an experiment. Okay, pause the video and just read through this. Okay, there's an example. We'll go through the example. Basically, the experiment is hands-on. You're controlling things. An observational study, you're just observing data. So, for example, a group of students wanted to know if there's a relationship between attending high school activity and GPA. They then use a survey. So they gather data. They're not manipulating anything. It's not like they're separating people into two categories and then exposing category A to some sort of treatment and then category B to some sort of treatment. All they're doing is observing the data. Use a survey to gather the data from students who do attend after-school activities. All right. So this is just an observational study. Whereas in this scenario, a group of scientists wanted to test a new drug. All right. They gather a random population of 200 alcoholics, and they divide them into two groups and then they take those two groups and have some sort of treatment. On group A, they treat them a certain way, and on group B, they treat them a certain way. One receiving the drug and the other a placebo. So they're controlling the experiment. Then they will collect data and see if the drug is effective. Okay, so your study designs, you have observational study, studies but does not alter what occurs, and experiment, the researcher intervenes to change reality, then observes what's happening. So here they're changing reality by separating, giving one group something and giving another group a different thing. Big idea here, something to note, is one major difference is extremely important. This will be very important throughout the class. Experimental studies are heavily based on cause and effect. The only way to get cause and effect relationship is through a well-designed experiment. And as we move through the course, we're going to talk about, well, how do you design an experiment well? How do you set up something so that maybe you can get a cause and effect relationship, like up here? Is there a cause and effect relationship between this drug that this group's getting, I don't know, to help alcoholics, I guess? Observational studies can never prove cause and effect relationship. Okay, so the only way to get cause and effect is a well-designed experiment. Okay, now you are not going to work in pairs, but now turn to page 11 of the book and work through these and just decide if they're observational studies or experiments. And that's it for today. I think there's a Kahoot attached to this that go along with this, so you have to take your Kahoot, and then that's that. Okay.